There's a number hidden inside reality itself. Richard Feynman saw it. He couldn't explain it. And 50 years later, physics still can't. It's called 1 over 137. Sounds boring, doesn't it? Except this little decimal controls whether atoms hold together, whether light behaves like light, whether you exist. Shift it by a fraction of a percent and the universe falls apart. So why is it that exact value? Stick with me, because by the end of this video, you're going to understand why Feynman called this one of the greatest damn mysteries in physics, and why nobody, in any lab on Earth, has ever managed to explain it. G'day, and welcome back to Curious Physics. Today, we're chasing a ghost. A number so weird it kept Feynman up at night, drove Wolfgang Pauli to obsession, and still has every physicist on the planet scratching their head. Let's get into it. Right, picture this. Caltech, the early 80s. Richard Feynman, the bloke who figured out how light interacts with matter, won a Nobel Prize for it, and basically invented the diagrams every physics student learns today. He's standing in front of a room. And he's not flexing. He's confessing. He says, and I'll paraphrase him here, there's a magic number in nature. We've measured it down to a stupid number of decimal places. We've proved it's real. And we have absolutely no clue where it comes from. Feynman literally told physicists to put this number up on their wall, to worry about it, to haunt themselves with it. Why? Because Feynman was a bloke who could derive things from first principles in his sleep. And this little number, this innocent-looking 1 over 137, beat him. It still beats everyone. Because here's the thing. This number isn't measured in meters, or seconds, or kilograms. It's pure, dimensionless. The universe spits this same value out no matter what units you use, which means it's not a quirk of human measurement. It's baked into reality itself. And Feynman knew it. In his book QED, The Strange Theory of Light and Matter, he basically begs the reader to find a meaning in this number. Is it related to pi? To e, the base of natural logarithms? To some clever ratio of mathematical constants? He even confesses that physicists have tried fitting it to all sorts of equations over the decades. Every time, the answer's the same. Nope. The number doesn't fit any pattern we recognise. It's just there. A signature with no signer. And here's where it gets properly weird. Physicists call this number the fine structure constant. They write it as the Greek letter alpha. And it's the answer to one of the most basic questions you can ask in physics. How strongly does light grab onto matter? Every time a photon, a particle of light, bumps into an electron, alpha is the dial that decides how violently they interact. Crank that dial up, electrons get yanked around like rag dolls. Turn it down, light barely affects them at all. Now here's the kicker. Alpha equals about 1 divided by 137.036. We've measured it to the 11th decimal place. We can predict outcomes using it that match experiments to absurd precision. But we have never, not once, derived it from pure theory. Not from quantum field theory, not from relativity, not from supersymmetry, not from anything we've ever cooked up. Every theory uses alpha. None of them produces alpha. Think about that for a sec. We can calculate the mass of a proton from quark equations. We can predict where Halley's Comet will be 3,000 years from now. We can simulate what happened a fraction of a second after the Big Bang. But this little number? We can only measure it, never explain it. It's like opening a recipe book and finding instructions that just say, add 1 over 137 of magic. No reason given, no source. It just sits there, written into the laws of physics, daring you to ask where it came from. Now here's the part that breaks people's brains. If alpha was even slightly different, you wouldn't be watching this video. Not because YouTube wouldn't exist, because you wouldn't exist. Bump alpha up by about 4%, stars stop fusing carbon properly. Carbon's the backbone of every living thing on Earth. No carbon, no biology. Game over. Drop alpha down a few percent the other way, atoms become too loosely held together. Molecules can't form, chemistry doesn't work, life can't even get started. Push it further in either direction, and the periodic table itself collapses. The universe becomes a cold, empty soup of light gases. Forever. So this one number, this 0.007974, give or take, is literally the difference between a universe with stars and planets and brains and curiosity and a universe that's just dead space. And the maddening part? Nobody put it there on purpose. Nobody set the dial. As far as we can tell, it just is what it is. Imagine you walked into a room and found a single key on a table. Just one. And someone says, mate, that key opens every door in the universe. Without it, nothing works. You'd want to know where the key came from, right? Who made it? Why does it fit? That's exactly where physics is right now. We've got the key, and we have absolutely no idea who made it. Now, I know what some of you are thinking. Surely some smart physicist has cracked this by now, right? Yeah, fair question. People have tried. And what happened next is genuinely one of the strangest stories in 20th century science. Wolfgang Pauli, Austrian physicist, Nobel Prize winner. The bloke was so brutal in his criticism that there was a running joke in physics. When Pauli walked into a lab, equipment would mysteriously break. They actually called it the Pauli effect. Pauli became absolutely obsessed with 137. He spent years of his life trying to derive it, trying to find some deeper theory that would just spit 1 over 137 out of pure mathematics, the way you can derive pi from a circle. He never managed it. Nobody has. And he wasn't the only one obsessed with this number. Sir Arthur Eddington, one of the greatest astrophysicists of his era, the bloke who proved Einstein right by measuring starlight bending around the sun in 1919, got so fixated on 137 that he convinced himself he could derive it. He published papers claiming alpha was exactly 1 over 137. No decimals, just 137 flat. Which would have been brilliant, except more accurate measurements eventually showed alpha is closer to 1 over 137.036. Eddington was wrong. He'd basically forced the number to fit his theory and ignored the messy bits. It's been a cautionary tale in physics ever since. If a man as brilliant as Eddington can fool himself chasing this, what hope have the rest of us got? And here's where Pauli's story goes from interesting to genuinely eerie. When Pauli was hospitalized near the end of his life, he was wheeled into a hospital room. Want to guess the room number? 137. True story. Look it up. He looked at his colleague who was visiting and said, basically, I'm not getting out of this one. He didn't. Now, I'm not saying numbers have mystical powers. This is a physics channel, not a numerology one. But I am saying this. When one of the sharpest minds of the 20th century spends his entire career chasing a number, and that number follows him to his deathbed, you start to understand why physicists get a bit superstitious about it. But here's the question Feynman couldn't shake, the same one nobody can answer today. Why this number? Why not 1 over 100? Why not 1 over 200? Why not pi divided by something neat? Modern physics has theories. The Standard Model, our best description of all the particles and forces we know about, uses alpha constantly. But it doesn't explain alpha. It plugs the value in by hand, like cheating on a maths exam by writing the answer at the bottom of the page. Some physicists reckon string theory might explain it, but string theory predicts a multiverse where alpha could take basically any value, which doesn't really answer the question. It just says, oh, in our universe, it happens to be this. Cool. But why? Other physicists wonder if alpha isn't even constant at all. Some experiments looking at light from quasars, galaxies billions of light years away, have hinted that alpha might have been very slightly different in the early universe, by a few parts per million. The data is still controversial, but if it's true, it would mean this fundamental constant isn't actually constant, which would absolutely break physics in the best possible way. Right now, in 2026, the best minds on Earth, at CERN, at the Perimeter Institute, at the quantum labs in Sydney and Melbourne, are still chasing this thing with super colliders, with atomic clocks accurate to 1 part in a quintillion. There's an experiment over at Fermilab in the United States called muon G-2 that's measuring how a tiny particle called a muon wobbles in a magnetic field. The wobble is controlled, you guessed it, by alpha. And the results have been hinting at a tiny discrepancy with the standard model. Maybe new physics, maybe just experimental error. Nobody knows yet. Every announcement, every new measurement brings physicists out in droves, hoping this is the breakthrough that finally tells us where 1 over 137 came from. So far, nothing definitive, just whispers. So what did Feynman actually see? He saw a hole in physics, a gap that no equation, no theory, no genius has been able to fill. He saw the universe's signature scrawled across the laws of nature, and we still cannot read the handwriting. Here's what I love about all this. We live in an era where it feels like science has explained pretty much everything. Gravity? Sorted. Evolution? Sorted. The Big Bang? Mostly sorted. But buried inside our cleanest, most successful equations is this one little number that keeps saying, nope, you don't actually understand me yet. And maybe that's the most beautiful thing about physics. Not the answers. The fact that the universe still has secrets, even from the smartest people we've ever produced. Feynman once said, the joy of physics isn't in knowing, it's in trying to know. So if you got a bit of a shiver when I told you nobody can derive 137, that's the curiosity Feynman was talking about. Hold on to it. If you enjoyed chasing this rabbit hole with me, smash that like button, hit subscribe so you don't miss the next one. And tell me down in the comments, what's a piece of physics that breaks your brain? I read every single one. And next week, we're going somewhere genuinely terrifying. What really happens to time itself if you fall into a black hole? You won't want to miss it. I'm Abdullah. This is Curious Physics. And the universe is still keeping secrets. Cheers, mate.